Let's see this. Consider the cache has 4 blocks for the memory references, and memory references are given like this 5, 12, so on. What is the hit ratio for the following cache replacement algorithms? So they are talking about first in first out, LRU, direct mapping, two-way set associative. Now in every case we are going to have 4 only, right? So 4 cache blocks. Let us say 4 cache blocks are like this. Okay, now let's talk about first in first out. So whenever 5 is not there, we are going to get 5, right? So whatever you write here or you strike off and write, that is going to be a miss. Why do you write here? Because it is not already present. That is why we can count, right? So whatever I am going to write, that is nothing but a miss. So 5 and then 12 and then 13 and then 17. So which one is the first to have entered this? So the first one that has entered is 5, isn't it? Okay, so next one that I have to replace is, I have to go for 4, so I have to replace 5, 4, and 12 is already there, so no need to replace it. And what about 13? 13 is already there, no need to replace it. 17 is already there, no need to replace it, right? So since they are already present there, I am not writing them again. Alright, therefore in case of first in first out, you can keep track of it that way. Whenever I write the number, then that is the miss. Okay, so 17, and what about 2? 2 is not there, so I have to replace the next one. So which one has to go out? The one which has entered first. So 12 has entered first out of all this now, so 2. And what about next one? 13 is already there. See, since it is not least recently used, you need not move it. Okay, it is all about which one has entered first. That one has to leave, irrespective of whether it is recently referred or not. That is why don't worry about LRU. Just see whichever has entered first, throw it out. Now 13 is already there, and what about 19? 19 is not there, so you have to throw out 13 only. What about 13? 13 is not there, so throw away 17. Got it? And what about next one? 43. 43 is not there, throw away 4. What about 61? 61 is not there, throw away 2. What about 19? 19 is already there, so leave it there. Now see how many numbers you have written here. That is nothing but the number of cache blocks we have got outside from the main memory, right? So everything that you wrote here is a miss. Now how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 are misses. Now how many is the hit? So count all of them. So how many total references are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So out of 15, 10 were miss and 5 were hit. So hit rate is 5 by 15, isn't it? The total number of hits divided by total number of references into 100 is going to give you hit rate. What is the miss ratio? The misses divided by total number of references into 100. Got it? So this is going to be 1 by 3 into 100. So 33.33 is the answer for that. Okay, what about LRU? So in order to deal with LRU, you need not use a list like this. Okay, so the way is, you can use a linear list and you can find out which one is least recently used in that list. So initially 5 is not there, and 12 is not there, and 13 is not there, and 17 is not there. So all of them will be present in our initial list, which means these 4 blocks are present in our cache. Now here, in order to find out the misses this way, it will be difficult because you will be cancelling out and rewriting the numbers again. So don't count the number of numbers here as the number of misses, right? So instead you write there only. So 5 is a miss, and 12 is a miss, and 13 is a miss, and 17 is a miss. Now what is that you are referring next? 4. So 4 is not present, therefore it is again a miss. Now it is already full with 4. So which one do you want to replace? The first one is the least one, which means the leftmost in the list is the least recently used. Therefore you have to replace this one with 4. Alright. And what is the next miss? Next miss is 12. Next reference is 12, but 12 is already present there. Therefore it is a hit, isn't it? But then just try to move it up the list so that you will remember that it is the most recently used as of now. If you leave it here, according to our our procedure, you will feel that it is the least recently used. But if you move it up the list, then it is going to help you remembering that it is the least recently used. Okay, and what is the next one? 13. So 13 is already there, which means it is also a hit. Okay, hit or miss, you look it there, don't look at this. And for only replacement you are going to look at this. Okay, now 13 is again now referred, which means it is most recently used, therefore you should move it up the list and pull it here, right? Why? Because if you look at from here, the least recently used is 13, sorry, the most recently used is 13 and then 12. The most recently used is 13 and then 12, that is the reason. And what is the next one? 17. So 17 is already present there, therefore it is a hit, and therefore you are supposed to move it up the list. So 17. And what about 2? 2 is not present there, so it is a miss, and so this has to be replaced. The least recently used as of now is 4, it has to be replaced with 2. Right? And what about next one? 13. So 13 is already present here, therefore it is a hit, but then try to move 13 up the list, which means 13 is going to be here. What about 43? 43 is not there in the list, isn't it? 43 is not there in the list, so you have to replace it. So which one? 12 has to be replaced with 43. And what about next one? 61. 61 is not there, you have to replace something, so 17 is going to be replaced, right? So what are there? So 13, 43 was a miss, so 19, oh, I have lost the track of it. I think I missed out 19 somewhere. So after using 13, the next one that is referred is 19, isn't it? So not 43 and this, the next one that is referred is 19, right? Therefore I have to get 19 here. Now which one is replaced? So in order to get 19, also here 17 has to remain, and I think 13 is 12 is replaced with 19. Got it? Okay, so now 19 is a miss, and next one is 13. So 13 is already, okay, 13 is here, so 13 is supposed to be here. Oh, 13 is not there, is it? Yeah, 13 is here. So 17 to 13, 9 are there, and 13 is there, which is a hit. Okay, and the next one is 43. So 43 is not there, therefore it is a miss, and which one should you replace? 17 has to be replaced with 43. And 61 is not there, which means it is a miss, and which one has to be replaced? 2, right? Therefore it is going to be 61. And 19 is there, therefore it is a hit. Got it? So finally these 13, 19, 43 and 61 are going to be in the cache. And now if we have to find out the hit rate, so total out of 15, how many times we are hit? So out of 15 you are going to get 1, 2, 3, 4, 5, 6. So 6 by 15 into 100 is the hit rate of this LRU. So don't think that from this example LRU is better than FIFO. In this example it happened so, right? It may vary, these numbers vary from case to case, therefore don't directly derive it, go to any conclusion saying that this one is better than this. That varies from example to example. Okay, next one is direct mapping. In direct mapping we don't have any option, you should directly, it is not like you have any choice, right? So what happens in direct is, for every main memory block there is already an assigned cache memory block, cache block, to which you have to replace it, right? To which it has to be mapped. That is direct mapping. Now 0, 1, 2, 3. Now whatever numbers I write here can be considered as misses. So initially 5 is not there, so it has to be written here, and then 12 is not there. Oh, I should not write it here, right? So 5 is not there. Where should I write it is, find out the number of cache blocks, that is going to be the size of the cache blocks, right? So you take this size in number of blocks and you divide each memory this memory block number with that number. So here the size of the cache is 4 blocks, therefore you take the block number of memory, main memory, and you divide with 4 and you get the remainder and you put it there, right? Which means if I have J as the main memory block number, then the cache block in which I have to put this one is, the J is J mod C, where C is the number of blocks in the cache. Got it? So you have to get this number. Take the main memory block number and you divide it with the number of blocks in the cache, and you get the remainder, and that remainder is going to give you the cache block number into which you are supposed to place the main memory block. Okay, now what happens with this? 5 when divided with 4, the remainder is 1. Therefore you are supposed to place it in 5. And what about this 12? 12 when divided with 4 is going to give a remainder of 2. So 12 has to go here. What about 13? 13 when divided with 4, the remainder is going to be 1. Therefore you are supposed to put it here, but it is already full. That is why replace it. So 5 has to be replaced with 13. Got it? So whatever numbers I write here, they are all misses in this case. Now what about 17? 17 is again here. 4 here. What about 12? 12 here. 13 here. And again 17 here, 2 here, 13 again here, 19 means 3, 19 here, 13 means here, oh 13 is there, therefore you need not write it again. And then 43, so 43 is 3, right? And then 61 is 1, and then 19, so 19 is it has to go here, right? So out of all this, only one hit was there, if you remember it. So in this example I remembered. So if you remember it, only for 13 it was a hit, right? For all of them it is miss. Otherwise we can count them. How many misses are there? 1 2 3 4 5 6 7 8 9. Okay, you should have kept 2 here. Anyway, the answer is not going to change, right? But 2 has to be here and 12 has to be here. Okay, now if you observe this, in the entire process, 13 is the only number which is actually, we got hit. So out of these 15 references, only one hit is there. So 1 by 15 is the hit rate for this, 1 by 15 into 100. Got it? So for direct mapping, for this example, it looks as if this is the worst method, right? But then it may vary from example to example. Okay, next one is two-way set associative, and LRU is used. So you have to divide the cache into sets of size 2 each. Therefore you are going to get only 2 sets. So set 0 and set 1. Now the first set is going to contain 2 blocks and the second set is going to contain 2 blocks, and now LRU is used within each block. Okay, now what about first one? So here you are going to maintain the list. Okay, so here we have to do 2 things. One is maintain the list and also maintain the hit and miss there. So first thing is 5. Which set it should go? Take 5, which means the main memory block number, and divide with the number of sets, and you take the remainder, that will give you the set number. And once you get into that set, if it is full, then you use LRU to replace. Got it? Okay. Now what is first one? First one is 5. First one is a miss. I am writing it below. Okay. First one is a miss. So 5 has to go here. Why? 5 remainder by 2 is 1. That is why 5 has to go there. And there is place, so I am writing it there. And what about 12? It is a miss. But then 12 has to go here. And what about 13? It is a miss. So 13 has to come here. What about 17? It is a miss. Now 17 has to be placed here only because the remainder is 1. So you can also think of it as even numbers here, odd numbers here, since it is only 2 sets, right? Okay, 17 has to come here. So replace this 5 with 17, right? And you keep track of this list. That is going to tell you which one is least recently used. Okay. And then 4 is not present there, so it is a miss. And get the 4 here, even number. And then 12 is already present there, but then move 12 up the list. It is important. Okay. So 12 is already present there, hit. What about 13? 13 is already present there, hit. But then move it up the list. Okay. What about 17? 17 is already present there, hit, but then move it up the list. And then 2 is not present there, therefore it is a miss. And which one has to be replaced? the one which is down the list, which means 4 has to be replaced and it has to be replaced with 2. And what about 13? 13 is already present there, hit, move it up the list. What about 19? 19 is not present there, therefore it is a miss. Now which one should you replace out of these two? 17, right? 17 has to be replaced with 19. Now 13 is already present there, therefore it is a hit, and you move 13 up the list. What about 43? 43 is not present there, so you have to replace what? 19. So 19 has to be replaced with 43, and 43 was a miss. And what about 61? It is a miss. 19 is also a miss. Got it? So now here you count how many hits are there out of 15. So 1, 2, 3, 4, 5. So 5 hits were there. Therefore 5 by 15 is the hit rate for this two-way set associated with LRU. 5 by 15 into 100. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.